Alright, so we're back, and this is going to be the start of the furnace project. So I've already got one wood furnace going for one of the shipping containers, and that may or may not eventually get plumbed into the train room. High probability it will. But we got the camper in a different spot. Camper is where the train room used to be. Or, no, train room is where the camper used to be. That's what I meant to say. But now where the camper is, there is no furnace for free, wonderful heat. So we need to fix that. And this is how we're going to start doing it. I acquired a furnace on Marketplace a few weeks ago. And this is going to be the frame for it. This is the base of some sort of enclosure to kind of put a roof over it, you know. So this is the piece that I cut off of the other frame. So the other frame was identical to this one. It had the two things welded in there. So what we're going to do now is just, clean up some of the steel on both sides and then weld this thing together. Then we're going to fork it over into the garage and put the furnace up on top of it. I may even throw some concrete blocks under the corners here because the plan is to utilize those holes, and we'll tapcon into some concrete blocks to kind of make a good solid foundation for this thing. All right, let's get into it. Jump on the tripod here, and that should work. I noticed in the last video I was filming on the trailer, the microphone kind of cuts out with obnoxious amounts of noise. So hopefully that's still the case here. I got my little 12-volt Bosch angle grinder, which for this kind of work, it is perfect. I love it. I like my Bosch 12 volts. They are the best. Oh man, more battery issues? Come on. Okay, that should be good enough. So when I was plasma cutting this thing off of the other the other frame, I didn't realize that they had welded everything from underneath as well. And so I'm sitting there like gouging and gouging and gouging, and the thing wouldn't separate. So finally, I was like, "What the heck?" So I just started cutting straight across it, figuring, that would solve my problem, and it still wouldn't come off. So then I flipped it upside down, and that's when I realized that when they built the frame originally, they had everything upside down and tack welded it. So I had yet to, cut through the tack welds, and that's why it wouldn't come apart. So that's why the one side doesn't look like the other, but it's not that big a deal because, it's not like we're putting millions of tons of pressure on it, and, it needs to bear ridiculous amounts of weight. So now I just got to get the welder hooked up here. and find hopefully. Oh man, I need to make a ground. There we go. Need my little hat. Do I need a glove? Yeah, I guess I'll wear a glove. I can only find one glove. Better than no glove, I guess. Helmet. Oh, that's right. The shade and this guy is on the outside. Yeah. Crank up the voltage. Power on. Alright, here we go. I should move that battery out of the way. Good enough. I always like to unplug the welder when I'm done using it, just in case we get a transient going through the power grid. You know, like lightning or solar flare or anything crazy like that. Okay, so now I guess, well, I was able to stand in this thing earlier. Maybe I'll just drag it. You know what? I'm just going to use the tractor. Hell with it. Sorry about the, whatever that effect was. Alright, so we're just going to pick it up with the tractor, I think. Oh, it's just the door moving. Someday, Chipper. Someday. So the other positive about putting that piece in the center there is you see that it catches the pallet forks in a better spot. If I had put the 48-inch forks on this tractor, I would have been able to reach across, but that set of pallet forks is underneath that little shed right there, because it's how we're moving that shed around. So, all right, we're gonna cut here quick while I get the garage door opened up, and then we're gonna go find the furnace and put it on there. All right, so got your reposition there, and I just gotta pull the furnace out. And luckily for me and everybody else, there's a lifting ring on the plenum of the furnace. So in order to lift it, I just throw a strap through it and then pick it up. Super easy. Oh, she's a little heavy. Or I should say he. Being that it's a wood furnace and it requires all kinds of manual labor to make it go, I would think that it would identify as a masculine entity. That's just how I feel about it. There we go. So it was just at the lip of that front beam. So I wanted to make sure that I was able to get the front edge of the furnace up onto the beam. Oof. And it's got a little bit of heft to it. I wanted to make sure I was able to get it up in place while I had the tractor attached to it, and it was easy to do so. All right, well, let's bring you over and give you a tour. Introduce the new character to the channel. So, this here is a Royal wood furnace. Royal meaning that's the brand name. It's not like, a title of nobility or anything. So, I'm not an Esquire, so I can't run for president. Yeah, that's one thing the South tried to get rid of, That's why I got no qualms with using Alabama state color on my equipment. Anyway, try not to let my political whatever's burn through or shine through or whatever. Anywho, this furnace, this is hopefully going to keep us nice and toasty, as long as we need it. Let's see, yeah, we can see the inside. That looks pretty good. Brick looks okay. I'm going to, redo the brick. Whatever that thing is up there, that needs some work. First thing we're going to have to do here is get the outer jacket off. What is this? Oh, that's the grate shaker. Interesting. Yeah, that sort of works. First thing we got to do, get the outer panels off, and then go through a heat cycle with a smoky fire to see if there's any cracks in the firebox, which would allow smoke and carbon monoxide to go into the plenum and then through the blower into the living space. So that's a good rule of thumb. If you ever buy a secondhand wood furnace or coal furnace or anything, is you have to strip it down to the actual firebox, which is the thick steel, steel wall on the inside where that contains the heat. Which, if I bring you up here, you can see that's the firebox. Seems like it's pretty thick, so I gotta imagine that this is a well-made furnace. And you can see they welded that lifting ring on there. So in order for that to support the entire weight of the whole furnace, I gotta imagine that the firebox itself is pretty stout and well made. So there's our thermostat, or I should say temperature sensor, whatever, probably both. There's the other end of it. Thermostat for inside the plenum. So that's what kicks on the blower motor when the temperature gets hot enough from the fire. There's our blower down in there. Tested it at the guy's place when I was there. He plugged it in. Blower works, doesn't make any stupid noises, so that's positive. Sides are a little dinged up, but I can bend them back. That's no big deal. And then after I get it stripped down to where we can see the guts and everything, I may weld or tack weld the furnace itself to this steel frame. And then just make it one unit. So then this is basically like mounted on a pallet, or like a skid, and then I'm able to pick it up with the tractor and move it around as necessary, and then get it in position. It's up off the ground. It's it'll have air underneath it. Hopefully that'll keep it from rusting, as well as air gap for fire's sake. You wouldn't want to put one of these on a wooden pallet. You would probably be okay if you had a good stout wooden pallet, and then you put concrete pavers on it, and then put some edging material around the pavers to keep them from moving around, so there's no gaps form over time. Because you got to remember, the blower motor is going to make the whole thing vibrate. So if the pavers are not locked into their position, they're going to kind of start to vibrate and migrate around, and get gaps between them, which hot embers could fall down in. And if you have all that sitting on top of a wood floor or wood surface, now you've got an ignition point for a fire. So yeah. So where that what is that? Is that ginger ale? Yeah, that's a Canada Dry ginger ale can stuffed there in the air hole. On my other furnace, I have a 3-inch electronic butterfly valve. That it's a 24-volt butterfly valve, and I actually have it hooked into Home Assistant on a relay pack with temperature sensors in the furnace itself and in the exhaust stream. And I'll show you that at some point here in the future while we're working on this guy, because we're basically going to duplicate that whole setup right here. So, and then that thing on the front there looks like it's about the right size. I don't think I'm going to have the valve hanging right out in the front there. I'm probably going to throw like a 90-degree on that and have the valve around the corner. And then just put some, heavy enough gauge piping around the corner to the butterfly valve, so that as I'm loading wood in there, it's not, banging it up and crushing it and creating problems. Definitely not going to use like the accordion style vent material. I'm pretty sure Lowe's sells the 3-inch heat pipe, or it's like exhaust pipe, or air inlet pipe for pellet stoves. I believe it's 3-inch, and they have that in straight sections and 90s and stuff like that. So I'm probably going to use that material there, and then relocate the butterfly valve around the side. Basically, the butterfly valve controls airflow, air delivery. There used to be, apparently, according to the guy who bought this, there used to be an electric blower on the front of that. And the previous owner, to him, said that one day it malfunctioned or something, and then this whole thing got cherry red, which is why you see that big scorch mark on the side there. So, again, that's another reason why I want to tear this thing down and visually and smoke verify the firebox. You have to get it up to temperature. You have to light a fire inside of it, actually get it up to operating temperature, and look for any cracks where smoke could come out, or any hot spots. You'll actually literally see it glowing if there's a hot spot. That you want to like check and visit with the welder before you put this thing into service for the long term. Um, yeah, I mean we got to clean the ash out of it, get our electronic management hooked up to it. It's just a simple thermostat and home assistant that controls the relays, which opens and closes the butterfly valve. So the butterfly valve has a common ground, and then two different voltage positions. Um, so that, or is it a single voltage position and two commons? I don't know. At any rate, um, it powers itself shut and installs, and then it will power itself open and then stall. Made to do that by design. So it's a stall motor on a servo, and a little servo that runs the butterfly open and shut, and that's how it controls the air, which controls the burn, which controls the furnace. I have used it to great effect on the other furnace. The issue there was, I would try to set that furnace to do a proper slow burn, and if I didn't get this door at the right opening, and if I didn't get this flapper valve at the perfect position, it's like I'd have to wake up in the middle of the night because it's either flaming hot or freezing cold. And then, my circadian rhythms really appreciate that. Um, After I digitized it and Skynet took over, it's been happy as a clam, and my sleep is a lot better for it. So that's what we're gonna do with this guy for sure. Um, Very minimal stuff. We need a power. We need a 24-volt power supply, a 12-volt power. Actually, no, we can, because those relay boards that I've got, they are 12 or 24. They go to like 5 volts to 28 volts. So a single 24-volt power supply, DC power supply, the valve, and a relay board, and some temperature sensors. What do I use? I use thermocouples. So I use these industrial grade thermocouple sensors that you get on eBay, and they work pretty well for that application. They're rated for high temperature. They come with a threaded fitting, so you can screw them right into like a bulkhead or a pipe or stuff like that. So yeah, this is the start of yet another project, and this is going to keep us toasty warm. So you'll see how I hook this up to the camper, and basically I need some takeoff collars there and there. I mean, I may need to reduce those holes because those look like they're 12-inch, maybe. Um, Everything that I do here, I do 10-inch ducting, the flexible ducting, because that's the largest size they sell at Lowe's, and they stock it all. It's a well stocked item, so you're always guaranteed to be able to get it when you go there. It's never out of stock. Um, because during the winter, the wind gets whipping up here at the property like crazy. Like we get, you know, 50, 50-mile-an-hour wind off of Lake Ontario. That's the norm. So, um, Jesus, I've been monologuing quite a bit here. Anyway, the ducting takes a beating. Sometimes it needs to be replaced. And my philosophy is I want something that's off the shelf, readily available, that I can just go get and not have to wait for. One thing we will do different with this build is I'm going to get some 16-inch HVAC PVC hose, which is like the stuff you see them using at like temporary venues where they hook up the big air handler trailers, the air conditioning trailers, and they have those big accordion ducts going into the tent or whatever it is. Or sometimes you'll see them when they're doing like asbestos abatement or construction sites. It's the big yellow hoses. I'm going to get that, and we're going to put the flexible HVAC insulated duct inside that to better protect it from the weather. um, that's key. because after enough sun exposure, the outside jacket of the HVAC duct fails, and then you get water coming in from either snow or rain. And then once the insulation gets wet, all of the little air pockets inside of it go away, and then you lose your R value because it's no longer insulation. It's like paper mache, and paper mache is not a good resistor of heat transfer. Spun glass insulation works because it's mostly air. The glass takes up, forms like a little matrix inside there of all these little cavities and crevices, which are full of air. And, air pockets like that is what prevent heat transfer. So, enough of me rambling. Let's call this a wrap. And now you have yet another project to look forward to. I still have to finish the generator project. Actually, let's go look at that real quick. I got to drag a bottle down here, hook it up, leak test still. I haven't done that yet because I actually ran into a problem. So your Memby, how is supposed to possibly replace that valve because I didn't know if it was bad or not. Well, at this point, it is definitely bad because when I was in here the other day working, I snagged one of these wires with my elbow and ripped it right the hell out of there. So at this point, this thing is live. So if I flip this switch, you'll hear that solenoid fire because I jammed the wire back up in there. So technically, this thing should run at this point. If I can get to it today, I'm going to drag the 100-pound bottle down here that's like partially full and do a quick leak test. We'll get the soapy water out, spray it down on all the fittings, and see what we get. And if we're good to go with that, then I may attempt to fire this thing up. Oh yeah, I still need to put this ground together. That's why I haven't done this. See, the ground has yet to be brought to its permanent home. So I do have some blocks for that, some terminals. So I got to do that. Yeah. So I need to finish the ground, do everything properly, ground and bond, and then we'll perform a leak test and maybe see if we can get this thing to fire up. We're just going to leave the breaker shut at this point. The other thing, I may have to do some troubleshooting with the wiring here because the transfer switch, last time I tried it, is still unable to fire that valve. So I don't know if something got jostled or what. I'm going to have to get the multimeter out, check for voltage on the circuit for the valve, the lockout valve. Make sure that all the wiring in the actual board command is happening the way it's supposed to. But as you can see, the valve works. It's just a case of, transfer switch ain't able to do the same thing. But I'm also going to get gas hooked up to this here shortly after I do the leak test, and maybe it is working because as soon as you hit the button on the transfer switch, this thing starts cranking, and I can't tell if it's working or not because it's so loud. I suppose I could put a 12-volt bulb in line on that wire there, and if the light is lighting up, then that's also a good indicator of what should be happening. You know what? I might do that anyway, just to have a visual indicator that the circuit is working, so that it's just one more way to get information and sanity check the thing. I'm gonna hit the button here, so it's ready to go. It's just it needs fuel and a ground, and hopefully that's all it needs, and not any further tinkering. So this kind of turned into a longer video than I anticipated because, go figure, I like to talk. Anyway, have a good one, people. Happy Sunday evening, and I hope the quantity of content and quality of content that I put out this week, especially the new microphone, brightens your day, How much is that guy? Have a good one, people.